So today we will see about the impulse function. Coming to the impulse function, mathematically it is represented as delta of t. Coming to graphical representation means on a chart, on a graph paper, how you are going to represent the impulse function. So the x-axis is the time axis, y-axis is the amplitude axis, that is for different instants of time from minus infinite to plus infinite amplitude is plotted. So this will be your impulse function. Note that at t is equal to 0, amplitude is equal to infinite. So definitely you cannot draw an infinite line. So you draw a line of finite height and mention it as amplitude is equal to infinite. Also area under the impulse curve is equal to 1. So coming to the mathematical definition of impulse, there are two ways of defining. First way is delta of t is equal to infinite, t equal to 0 is equal to 0, t not equal to 0. So here this infinite is nothing but the amplitude. Second way of defining an impulse functioning is anyone can be used. Delta of t is equal to 1, t equal to 0 is equal to 0, t not equal to 0. So here we are saying infinite. Here infinite means amplitude. Here we are saying 1 in the definition. This 1 corresponds to area under the impulse curve. So here we already told that area is 1. Here it is stating about amplitude is infinite, but we have to incorporate this area information in representation 1. Hence for in method 1 we apply delta of t is equal to infinite, t equal to 0 concept. We also apply area is equal to 1 concept, that is area under delta of t curve is 1, that is integration under the delta of t curve is 1, that is integral minus infinite to infinite delta of t dt is equal to 1. Now what is the specialty about the impulse function? After all, we cannot generate the impulse function in the lab. You cannot generate a pulse which has infinite amplitude in very short duration. But why it is very important means, so if you see Laplace transform of impulse response is equal to transfer function is equal to h of s. So any system is always characterized by the impulse response. So what is the specialty of the impulse response? The specialty of the impulse is, even though it cannot be generated practically in the lab, impulse is important because it contains infinite frequencies. How can you say that it contains infinite frequencies? For that, draw the spectrum. If you see delta of t forms a Fourier transform pair with 1. So if you see delta of t, any transform, dt of t, Fourier transform, Laplace transform, Z transform, any transform is 1. If you draw the spectrum in the frequency domain, that is with x-axis as frequency and my y-axis as amplitude, I am going to get a straight line, that is from minus infinite frequency to plus infinite frequency, my amplitude is 1. That is impulse function contains infinite frequencies. Infinite frequencies. And hence impulse is very important, and hence every system is represented by impulse response. That is, if you take any system, if you apply the impulse as input, it means that you are applying, say you consider any system and you are applying impulse as input delta of t, the output you get is called impulse response. Some system, so any system, when you apply impulse as input, the output you get is called impulse response. So any system, whenever you are applying impulse, it means that you are applying infinite frequencies to the system to get it. So impulse response is very important, even though impulse cannot be practically generated in the lab. Thank you. Subscribe to get more such critical concepts to become technical criminals.